Video 4. Conceptualizing intensity and the extent of intensity. This video introduces two ideas which might help the viewer to reinterpret the concept of products and multiplication as cognitive schemas. There are two distinctive ways of thinking underlying many concepts, reasoning in terms of intensity and in terms of the extent of intensity. Compare these two images. Most people will recognize the image above as a loose collection of building blocks. The stack of blocks can be appreciated as a collection of identical discrete elements, which could be grouped together at will. The collection could also be divided into parts right to the smallest discrete units, but no further. Division into units or their multiples is not possible in the case of the second picture, which is duplicated above. It shows the same image repeated within itself. Most people find the experience of looking at such pictures both familiar and disturbing. Comprehending the picture involves a distinct way of thinking, which does not involve wholes, parts, or elements. Let us discuss first a more obvious way of thinking, which involves repetition of a unit. It is typically associated with the notion of wholes, parts, and measuring, and the act of extending and contracting by multiplying and dividing. The notion of wholes assembled from elements is very familiar to most of us. It is not fully appreciated, however, that thinking in terms of parts and wholes relies on elements which are by their nature discrete and distinct. However small they might be, such elements always have some extent. For example, the concrete block on the right exists as long as it has a volume. This might sound trivial, but it has a few hidden conceptual consequences. Consider a line section cut into 3 parts and all its parts cut into 3 parts and so on infinitely many times. Dividing the line section infinitely many times produces smaller line sections which are as distinct and discrete as the line one started with. This is illustrated by the animation below, which for clarity depicts divisions of one section only. This is an aspect which differentiates extensive reasoning from other types of thinking. Dividing the whole into parts or elements infinitely many times will make ever smaller units, but will never produce the element of zero extent. This observation is consistent with the intuitive, non-mathematical understanding of multiplication as a process of replication and reproduction which always involves tangible entities. The situation is depicted in the cartoon on the next page. Unlike in mathematics, in everyday language the idea of multiplying always means an increase. Multiply simply means to increase the number or quantity of something by replicating, reproducing, procreating, propagating, breeding, etc. The corollary of these observations is that one cannot multiply anything having zero extent. For example, all points must have some extent or they would not be able to constitute a line. This is in agreement with the idea that all units, however small they might be, must have a well-defined size. In other words, all units are discrete and distinct. In summary, one cannot multiply nothing as nothing is not a unit. The idea of nothing is often thought of as a zero, which would mean that one cannot multiply zero because it is not a unit, but rather its absence. This raises an important question. If one cannot multiply 0, what is the meaning of 0 times 10 equals 0, or similar expressions? The answer could be found in what might be called intensive reasoning, which involves the notion of intensity, values, and many other related concepts. The notion of 0 is a part of such concepts as value, intensity, level, etc. In common language, one can always say that something has no or just 0 value. The object of 0 value still exists, even though its value is 0. As such, it could be multiplied with ease. The notion of zero exists also in the context of level-based concepts. For example, most people would say that level 2 in the figure on the right is above level 1, which is above level 0, which stands for the empty vessel. Empty containers can be as easily multiplied as the containers full of water or anything else. Such concepts as color value, intensity, lightness or darkness, brightness, saturation, etc. all involve the notion of zero. One can always say that colors have zero intensity, brightness or saturation, which stands for no intensity, no brightness or saturation. To see colors of no intensity, one has to use the organ, example cones and rods, capable of being activated by colors of various intensities. As units, the photoreceptor cells can be multiplied as easily as the objects and containers in the previous examples. All sensory organs involve multiples of units, for example pain, touch, vision, sound receptors, etc., capable of sensing intensity from 0 to some maximum value. The same applies to many measuring instruments. On the other hand, consider the objects of sensation or measurement, such as 5 tasteless apples. It is the apple which is replicated, and with it the absence of taste of zero intensity. Next, think of the same apples in terms of their color. Again, when the apple is multiplied, the brightness, lightness, saturation of its hue is repeated with it, and so on. Please note that most objects typically have more than one property, the value or intensity of which is replicated while the unit is multiplied. Consider an apple again. Brightly red, silky smooth, very sticky, intensely cold, very large, rather heavy, very fresh, average sweet, quite chewy, less than crisp apple. In each case, the apple is described by the intensive aspect of one property, which by definition also includes zero intensity or value. There are many other situations in which the notion of zero exists in the context of a unit, functional or otherwise. Once again, it is the unit which is multiplied, and with it its values, intensity, weight, importance, level, etc., or their absence. Each of the units in the examples above is repeated in terms of one particular intensive property, for example, monetary value, intensity of the color, volume or level, tone of the note, or height above the ground. To understand the concept of product in the next video, it is important to note that multiplying something produces the collection of elements sharing not only the same property, but also the same degree of its intensive aspect. The value of a dollar coin in the previous slide is the same for all coins. The intensity of yellow color does not change from square to square. The degree of shine, freshness, sweetness, or weight of the apples displayed below does not vary with the repetition of apples. Consider 5 apples from the previous example divided into 2 groups. Because the collection of apples is a multiple of the apple unit, the space between its parts must also be a multiple of the unit, but with a difference. The unit of space differs from the unit of apple only in terms of intensity. This is indicated in the animation below by the flickering apples outline to remind us about the unit both in regard to its extent and to its intensity. The space between the groups of apples amounts to 2 units of zero intensity. In the context of apples as objects of sensation, the space appears empty due to the absence of intensity. No object, no reflection, no intensity. But from the point of view of sensation of apples, the sensory units must be there, because without them one would not be able to sense the absence of intensity. On this account, space within and without the object, internal and external space, share the same unit and differ only in terms of intensity. Objects are those units of sensation, the intensity of which contrasts a low or no intensity of the background. Only in this sense space could be multiplied and still produce the same result irrespective of how many times it is multiplied. Compare the image of 5 apples from the previous slides with a nested picture of the kind displayed on the right. The image shows a unit, a picture of a person, repeated but in a different than previously way. The image is embedded, nested, inside itself. Even though the image is made of the same repeated unit, there is no way of dividing it into parts without destroying its integrity. Also, one cannot insert space between units by changing their intensity the way it was carried out in the previous slides. The image of nested units comes as a single entity, the space of which is made of units of different scales, such that the larger scale unit relies for its existence on the smaller scale unit, which relies on even smaller scale unit, and so on without an end. This way of arranging units seems peculiar to only few pictures based on Escher's Droste effect, but this is not so. The effect represents a very common concept found in both mathematics and in everyday life. Below are a few examples of fractals in which the units are nested. As a structure, nesting is more common than these few instances. The idea of magnitude, value, counting, cardinal numbers, ordered sets, hierarchy, infinity, functions, fractions, etc. in mathematics, and such notions as intensity, value, distance, area, volume, extent, height, depth, time, weight, mass, speed, density, concentration, pressure, price, levels, importance, status, prominence, significance, dedication, feeling, pain, and various other sensations and experiences, they all could be interpreted in terms of nested units. In fact, all concepts based on some extensive aspect could also be conceptualized in terms of nesting. To see this, compare the concept of levels with a Droste-based image. Figure 1 shows levels related to the bottom of the vessel. Figure 2 shows the same levels as a group of nested rectangles with their bottoms aligned. And Figure 3 shows the rectangles reflecting the arrangement of unit pictures in Figure 4. One can clearly see that the notions of levels and Droste figures represent structurally the same concept. The same procedure could be used to relate the nesting of fractions, Figure 1, and natural numbers in Figure 2. The remaining figures apply equally to both cases. Another example is the scale of Gray having 6 levels. Please note that the number of nested scales within the unit is not limited. The scale of Gray can be continuous, which implies an infinite number of gradations. The same approach could be used to demonstrate the nested nature in the case of concentration, density, etc., and all specific properties. In summary, there are 2 distinct ways of assembling units. One involves repeating the unit within itself, which emphasizes nesting. The other requires the unit to be repeated as a single indivisible whole, which emphasizes extent. Nesting of the same unit within itself is only possible if the subsequent units are scaled down without losing detail. In other words, they remain the same despite of being scaled down. Replicating, on the other hand, is only possible if the unit is repeated as a whole. In other words, the units are replicated as if they had only one scale. The next video outlines how the 2 ways of reasoning are combined into products. All ideas in this video come from a book published in 2014 under the title Conceptual and the Structure of Human Experience. The book can be purchased from Amazon. The research of human expressions suggests that humans tend to think in 2 distinct ways, which could be combined in various manners. The theory can be applied to various fields, one of which is mathematics.